if it's not apparent to you, it's actually a graph representing the relationship between advertising, the advertising budget on TV and the corresponding sales that might come in as a result. There's a bit of a, we're going to geek out now, so I mean there's no getting over it. A linear regression expert would take the algorithm here and apply it to the graph. They see much more in the graph than we do, of course. From a mathematical perspective, they can apply this equation where Y represents the sales expected from an input budget of X. Now there are some other factors here as well, but for example, the betas in this example, they represent the distance from the line and also the slope of the line. Now, you and I don't really understand the significance of that, but it really means something to machine intelligence, machine learning experts. And so the epsilon, by the way, is a coefficient of error. So they even blend in an area of doubt, a margin of error, so that you can put that into play as well. Now, if you correlate this equation and the graph with the time of day and other variables that come into play, the demographics of the person watching, the channel, etc., this algorithm would give a company a fairly accurate reflection on how much return could be expected from a particular investment into an advertisement. So really useful stuff. We could take, however, a naive Bayes approach to this. So a naive Bayes algorithm is applied to a similar graph looking like this, maybe let's say at Netflix, could show something completely different. And so we'll have a stab at that. Indulge me a little and let me for a moment fall into some archaic stereotyping. It's just for the needs of the example here. Okay, let's say this is a representation of a category known as rom-com movies on Netflix. Right? It transpires from the data that the green spots represent female viewers and the red spots represent male viewers. I'm just saying. All right, just stay with me. An algorithm like naive Bayes would look at the numbers and conclude firstly that there seem to be twice as many females who've watched this category of movie than male. It would then create a probability vector of which gender is more likely to view a movie from this category, and in this case, what the probability would be like. The actual equation they might use would look like this. Now, I've gone into a bit more tech than I need to, but you can work this out, that probability for green is going to be 40 over 60 if the total number is 60 as a data set. So that really equates to 2/3. Probability for red is 20 over 60, and so that equates to 1/3. And they then apply this equation here, and that's a naive Bayes approach to doing things. And if we really wanted to get techie, the machine learning expert would use this formula where you look deeper into the mathematics and then you add a few more factors there relating to what has maybe been watched before by that person. You would ask a few more questions of the viewer, and so that the algorithm can yield much more accurate results. It means that if these probabilities could be derived from the graph, then we can fairly broadly predict if the viewer is a female, there is an X% chance of them wanting to watch a new rom-com movie. Now, it is actually a really broad brush example, of course, as I've just said. It's far more complicated at Netflix than that. Things like which recent movies did they watch? What is their age range? What is the socio-economic profile of this viewer? These all come into play, and you could take these directly or from very subtle methods. You could extract these, this bit of information from each individual user. But the point is this, that important, raw data in this process firstly becomes a graph. The graph starts to show patterns. Algorithms, if you use the right ones, can put a very accurate mathematical spin on that graph, condensing it, digesting it and condensing it into a particular mathematical formula, to the extent that the algorithm can then predict What is going to happen when we stick an unknown entity on the graph? So for example, if there's something that is not there at the moment, but we wanted to see where you and I would fit on there, you would churn us through the formula or the algorithm, and it would put out a result which would plot us directly on that graph. So in this way, we can superimpose one graph upon another even and see if the machine learning system can pick up correlations. So for example, here's another one coming up. If this is a representation of the density of pizza chains across the US, a machine learning system could use a pre-programmed algorithm. It would spot the onslaught of diabetes by correlation to the geographical data with the BMI in this. So essentially, if we had feedback and data sets relating to BMI and pizza chain restaurants and geolocation, well, that would mean something to a machine learning system. Algorithms mean that machine learning systems could predict the onslaught of heart disease 1 year ahead of time because the data on previous patients could flag up the probability that a person with a certain age and a certain lifestyle living in X miles proximity to a particular pizza chain would be more susceptible to having heart problems in the future or diabetes problems in the future than others.